Hello everybody, my name is Goran Piskachev. I am a research associate at Fraunhofer IEM, where we closely work together with the Secure Software Engineering Group at Heinz-Nixdorf Institute. I will be the host of this lecture, and we are going to learn how to apply existing generic static analysis, for example taint analysis or type state analysis, to detect different kinds of security vulnerabilities in application code. To customize such generic analysis, we need so-called security relevant methods. And in this lecture, we are going to see how can we infer these methods coming from the application code. Let us start with the lecture. We are going to cover the following questions in this lecture. First, we want to see what are security relevant methods. So we are going to define them, and we are going to see several examples. Then in the most of the lecture, we are going to talk about how we can infer security relevant methods. In particularly, we are going to see examples from Java. However, the results and the research methods that we are going to discuss are not specific to Java, and they can be generalized to other programming languages. This part will cover recent research results that have been done in our research group. We are going to talk about two tools named SUSY and then SWAN, which are supervised machine learning approaches for fully automatic inference of security relevant methods. Then we are also going to see what SWAN Assist is. In short, this is an active machine learning approach for semi-automatic inference of security relevant methods. As you see here, we also are going to motivate why we need a semi-automation instead of fully automatic approaches. Then, as a prerequisite for this lecture, you do not have to have deep understanding of machine learning and all the mathematical models behind it. We are not going to discuss them. However, a basic understanding of classification problems will be very helpful for you to understand how these methods work. Then in the last part of the lecture, we are going to see how a generic taint analysis can use security relevant methods, and in particular we are going to see how this is done through domain specific languages, which are used by users of the taint analysis engines to configure the analysis and to specify different kind of security rules so that the analysis can work on arbitrary application code, and it can be extended with new security vulnerabilities. Okay, so the first part is seeing what are security relevant methods, and to do this we are going to start with a recap, and we have already covered FlowDroid as a taint analysis for detection of data leaks in Android apps in previous lectures. This is a very high-level overview that we have seen already. We have a taint analysis engine which is doing the data flow. It calculates data flow paths between different statements in the program. And FlowDroid expects a list of API calls, so-called sources and sinks, and tries to match these API calls in the application code. The application is also input to this engine, so we have an APK file, and FlowDroid is matching the method signatures of this API lists of sources and sinks and reports any paths, data flow paths that were found during the analysis as a result. And these are so-called data leaks. As you see, FlowDroid is specific to Android and it is only configured to work at the moment for data leaks problems. And what defines this as a security issue, so it actually is how we choose the sources and sinks. And in the context of Android application, one would like to find out, for example, whether confidential information stored on the device can be leaked through the application to other components or to other devices, or to be sent somewhere over any network. So, an examples here you see for sources are any API calls from the Android network that can get access to content of the SMS or location or calendar information or contacts. Sinks are typical examples here, as you see, like sending SMS messages or sending any information over Bluetooth or NFC, or message over email, or any connection to an internet socket. So this is these are the definitions of sources and sinks in FlowDroid, and this actually allows FlowDroid to find data leaks. To see some examples now, we have here location APIs. So these are typical sources that also FlowDroid uses. FlowDroid is aware of these signature methods. So we have the standard API calls for get latitude and get longitude, and this is provided as an input to FlowDroid. Then FlowDroid tries to match these signature methods in the application codes and find where these methods are called, from where a taint will be created. An example for sink is here the standard API to send a text message from the SMS manager, which, as you see, gets several parameters, and one of these string parameters is actually the message that will send. So this is a sink because the taint analysis needs to track if any existing taint created from a source can reach the parameter here for sending an SMS. If that is the case, then FlowDroid will create a data flow result which will be reported as a data leak. Okay, so we want to see some further examples of sources sinks, and we are now also introducing so-called validators. All of these methods, we call them security relevant methods, and they are actually triggering a state change in the data flow analysis. So let's see this through the examples first. So we are going to see again data leaks in taint analysis. So as we saw from the examples before, a typical source will create a taint. So this means the analysis is changing its state to a tainted state. And this will be, for example, the return value of the get latitude call in Android. So in the Android application, when there is a call to get latitude, our taint analysis, or in this case FlowDroid, can create a taint for the return value of this method. Typical validator in this context would be sanitization method or sanitizer. sanitizer will so-called kill the taint. In this case, that could be some kind of encoder method. Let's say we have any encode location from a specialized sanitization library. Usually these validators, like the sanitizers, are provided from specialized libraries, and they are written by experts. FlowDroid is not aware of such methods, so this is a limitation. If there is any kind of sanitization in the code, FlowDroid is not aware about this, and therefore this can be a reason for false positives in FlowDroid. So FlowDroid will report all data flows between a source and sink, regardless of any sanitizer that can be called on the path between these two statements. And then we also saw the example for sink. So a sink is actually a method call in the application that actually fires a data leak report if the taint is still alive. In this case, with the previous example, this would be the string parameter that contains the message of a send text message. Okay, so these are now examples for security relevant methods. Let's see one more example. So here we see how security relevant methods are defined for so-called access control vulnerabilities. And these types of vulnerabilities can be, for example, detected by type state analysis. In comparison to taint analysis, where we only have one state, the data flow will check if a taint exists or not exists, or it is in a tainted state or not tainted state. In type state analysis, one can model arbitrary number of states. And this is, you see a state machine example on this slide for authorization, firing and authorization problems. As you see, we have here 4 states. We have an initial state, and then we have A1 state, meaning that we are in an authenticated state of the program. So and then we also have A2, that means we are in authorized state of the program. So authentication means here that a user has entered the system and he or she is authenticated, while authorization means that this specific user can have access to a specific resource, or in this case we will use the notation critical method. So not every user that is authenticated may access every critical method. So that's why we have a 2-stage of access control. As you see, if there is a call to a method authenticate, we can move from NA state to A1 state, and if there is a call from to authorize, we can move from A1 to A2. It is allowed to call an authorization critical method only if we are in A2. If we call such method in NA or A1 state, then we are going to move to this invalid state CWE 862, which is the state where we want to fire a vulnerability report. Here CWE stands for Common Weakness Enumeration. We are going to see more examples of this. So these are standardized IDs of different types of vulnerability issues that have been documented by experts and collected in the community, so we can always address them. In this case, this one is about authorization issues. So a type-state analysis in this example can define, for example, any entry point in the program as a source. In this case, once we start analyzing the code, we are going to declare that we are in NA state, or we are not authenticated. Validators in this case are methods like authenticate and authorize methods. So these are methods that will change the state of our state machine. And then we can define the authorization critical methods to be our sinks. In such model, we can actually apply type state analysis and detect access control vulnerabilities. So these were two examples of security vulnerabilities. One was the data leaks issues that we have seen with FlowDroid, and then one was with access control vulnerabilities where we use type state analysis. Now we are going to see further examples. This slide shows you a list of the most popular security vulnerabilities, and this is a list created by the SAST Institute. They usually do some on several years they publish lists of most popular or most dangerous security vulnerabilities that happen in practice and are relevant. As you see here, they all have a ID. So we have CWE, which is, as I said, stands for common weakness enumeration. For example, SQL injection is 89. And then these are examples of how a source, a validator, and a sink can be defined in order to detect this security vulnerability. So as you see, most of these vulnerabilities can be to some extent modeled as a taint analysis, or sometimes will require a type state analysis. And all of these that can be modeled as taint analysis, we call them so-called taint-style vulnerabilities. And as you see, most of them can be expressed in this way. So SQL injection and OS command injection are typical examples here that are often found in the literature. A source is any external information coming to the application. For example, it can be a request in a web application, a request object that can carry any untrusted data from a user's input, like form on web pages and so on. So these are all data that should not be trusted. And in case of SQL injection, the taint analysis has to make sure that this untrusted input is not going to an SQL database. So in that case, we can define as sink any SQL statement executions, and there are many different sanitization APIs, like prepared statements in Java, which can be considered here as code sanitization, and they are in our categorization a validator. Or there can be other types of libraries that will provide any kind of SQL encoding. So as you see, there are other type examples. Let's see, for example, CWE22, we have a path traversal. In path traversal, we're going to define sources, again, anything external, so any external information that is flowing into our program, we should define it as a source. Then there are specialized path sanitizations that can be defined as validators. And then we can define any file operation as sink. Incorrect authorization, it's something we have seen. So this is kind of focusing only on the authorization problem. So we will have again entry point as source. We can have any critical function in our application can be sync. So any access to specific resource that needs a special role only to access will be defined as critical function. And then in the authorization methods, so depending on what kind of application it is, there are different kind of authorization mechanisms, and the analysis needs to be aware of those mechanisms so that it can define the validators. So this list gives us overview of many popular vulnerabilities, and we have classified them, as you see, the types of sources, validators, and sinks that can be used for each of these vulnerabilities. On the next, we are going to see more concrete example. So we are going to see this code now, and we will discuss what some examples of vulnerabilities here. So we have a handler method for HTTP requests. It's written in Java, named doGet. And as you see in line 3, we have a local variable user ID, which gets the return value of the method called getParameter. So this method is processing the HTTP servlet request, and this parameter with ID, user ID, will be stored in the local variable user ID. And as I said, anything coming from request in web applications should be considered as untrusted. So in this case, we don't want to, we have to be careful where this information is going. And we can, our data flow analysis, if we say we start a taint analysis here, and if we define getParameter as source, we'll track the taint through the program statements. And then here we see in the line 4 that the user ID is going through some method, but it's still stored again in the same variable. And then it continues in line 6, where we construct a string which is the SQL query. We have a select from where statement that concatenates the user ID value, and it assigns this to another local variable query string. And in line 7 we have an execute query statement where we give the query as an argument. So as I said, this getParameter could be specified as source, and this is like external source type. And then we have a sync here statement, execute query, which is a typical sync for SQL injections. So we have an operation with an SQL database, and this should be now our taint analysis should be aware, find this as an SQL injection vulnerability. However, as you see here, we have a call to encode for SQL. So this is like external library that we can use, and we provide the untrusted value as a second parameter, and this method will return a encoded value. That means this is now, in this point, our taint analysis should kill the taint at line 4, and therefore this should not be reported as SQL injection. So this is example for this vulnerability. And if we continue in the same code here, if we want to track further what happens with our user ID, if you see here at line 8 now, user ID will be again concatenated to some string, and it will create a URL. And in line 9 we have a sync, which is a send redirect method call, and we are redirecting the client to a different location. And this is a typical example for open redirect vulnerability. In this code, as we see, we do not have any validator or any sanitization for URLs, so this should be definitely reported by the analysis as an open redirect vulnerability. So in the same code we saw here that we have single external source which is relevant for two different vulnerability types, and we have two different sinks, one specific for SQL injection vulnerabilities and one specific for send redirect vulnerabilities. And furthermore, at line 4 we saw an example for sanitization of taints for SQL injections. These are all examples for security relevant methods. Okay, so this kind of taint analysis are very used now in practice and even in commercial tools and open source tools. Here are a set of popular tools that you can have a look at. Some of them are open source, for example spot bugs, find bugs, and infer. Some of them are commercial, for which you need a license, and some provide to some extent parts as open source, like SAML was recently bought by GitHub, and they provide their parts of their rules for the taint analysis as open source. We are going to see an example at the end of this lecture. So all these tools are now in community known as static analysis security testing tools, or SAST tools in short. And taint analysis is one of their key components. So many of these tools implement generic taint analysis, and this analysis can be then configured with different types of sources and sinks, so they detect different types of vulnerabilities. The hard part about this is finding these sources and sinks manually. This is always done by security experts. As you see, you need a domain knowledge in security in order to decide what are the correct sources and sinks, or validators as well. So this is a knowledge that is needed for the tools, and it is very time consuming and quite expensive to collect, because you have thousands of different kinds of libraries and frameworks, and they can provide different kinds of functionalities like connectors to databases. And as you see, you need to know the API methods for this. And yeah, that's exactly what we are going to talk about in the next video of this lecture. So we are going to see how can we automate this selection of security relevant methods, so we can speed up the process.